Welcome to SeaSalt's mixed reality simulator of ventriculostomy. This system provides a comprehensive platform for practicing the ventriculostomy procedure, also known as external ventricular drain or EVD placement. Designed for neurosurgery and emergency medicine training programs, and optimized for military and austere environments, this simulator delivers high-fidelity, repeatable training without the need for wireless connectivity or wet fluids. We appreciate the contributions of all researchers, engineers, and clinicians on this project. The complete system is portable, consisting of a computer workstation, simulated anatomy, tracked instruments, and a military-spec padded transport case with inbuilt wheels and telescoping pull handle. Designed for turnkey deployment, it can be unpacked and fully operational within 7 minutes by an unfamiliar user. The case meets airline-checked luggage size limits, and the packed weight is 50 pounds. The simulator integrates physical and virtual components, including a 3D printed anatomical head and skull, a scalp, a library of 140 virtual brains, including ventricles and brainstems, and tracked instruments, including a catheter loaded onto a stylet, a hand drill, and a virtual camera controller. It also features an automated feedback system and a replay function for debriefing, along with instructional materials to guide users through the procedure. This mixed reality system collocates virtual and physical components and uses 6 degrees of freedom, electromagnetic tracking to track all instruments, drill, EVD stylet, and camera controller at a 0.2 mm resolution in real time. The anatomical models are based on medical imaging scans of de-identified humans, ensuring an accurate representation of the structures encountered during an EVD procedure. The simulator is built on the SMARTS platform, the system of modular mixed and augmented reality tracking simulators, a modular system that enables rapid configuration, interoperability with other training modules, and scalable simulation environments. Anatomies are compatible across the SMARTS modular stand via quick-release placement and indexing. Visualization modes can be adjusted to support learning and debriefing. Users can toggle between 4 views: ventricles only, full brain, skin with landmarks, and skin only. These modes allow learners to develop spatial understanding of anatomy at different levels of detail. A tracked virtual camera controller enables dynamic viewing perspectives, allowing users and instructors to observe the procedure from multiple angles for improved assessment and feedback. The controller can also be used to mark target locations on the virtual skin, supporting procedural planning before instrument insertion. The tracked hand drill simulates the resistance of bone during burr hole creation. The software monitors how far the drill tip extends past the inner table of the skull during burr hole creation. The catheter is loaded onto a stylet tracked at its distal tip. The catheter/stylet allows users to practice the full sequence of EVD catheter placement with realistic feel and sub-millimeter positional accuracy, including a subtle tactile pop when penetrating the ventricle. The catheter can then be removed from the stylet and sutured into place. The simulator features replaceable skull inserts that include both inner and outer tables and a dura layer, providing realistic tactile feedback of bone and dural resistance. Each insert can be used up to 9 times before replacement. For programs focused on selection of burr hole location and catheter placement, optional pre-drilled skull inserts with a matrix of holes are also available. The simulator includes replaceable scalp inserts that allow users to cut into the scalp using a scalpel, separate the scalp with a retractor, tunnel the catheter under the skin, suture the catheter in place, and close the skin. At the end of the procedure, the scalp and catheter may be removed to reveal whether the suture needle penetrated the catheter. The simulator includes a library of 140 interchangeable 3D brain models based on real patient MRI scans. Each brain features variable ventricle sizes, creating a wide range of clinical scenarios. Brains with smaller ventricles present a greater challenge, offering progressive difficulty as learners advance, Cognitive aids can be enabled at any time to provide guidance on instrument orientation and target localization. These aids display a circular zone representing Kocher's point and the mid-pupillary lines, helping learners develop an accurate mental model of the correct entry point and trajectory before and during the procedure. At any point during the procedure, the user presses the spacebar to indicate they believe the stylet is correctly positioned within the ventricle. The simulator responds with, "CSF is flowing," or "CSF is not flowing," and displays a results panel showing how far the catheter tip is from the ventricle, as well as the volume of select brain regions swept or disturbed by the catheter. This immediate objective feedback reinforces accurate technique and supports reflective learning. Each session can be recorded and replayed, allowing users and instructors to review performance, analyze technique, and identify areas for improvement. The replay system supports structured debriefing and after-action review, making it a valuable tool for both self-directed learning and instructor-led feedback sessions. This mixed reality simulator enables safe, repeatable, and high-fidelity training for ventriculostomy. By combining physical realism with advanced visualization and objective procedural feedback, it supports the development of clinical skill, confidence, and procedural accuracy, whether in a hospital training program, an emergency medicine curriculum, or an austere field environment.